So in this problem, there is a box of gazelle treats. It's on a ramp at a 30-degree incline. Coefficient of kinetic friction is 0.3. The box is sliding down the incline, and the gazelle is very excited about that. So we want to find the acceleration of the box of treats as it slides down the incline. So now let's solve that problem. So let me get rid of this. We begin with our pictorial representation. This is theta equals 30 degrees. So here's the box of gazelle treats. It's sliding down the ramp. The mass is 6 kilograms. Coefficient of kinetic friction, UK, is 0.3. So what are the forces acting on this box? Well, we have force of gravity. So force of gravity, which is mg. We also have the normal force. And since it's sliding down the incline, there's going to be force of friction up the incline in the direction opposite to the direction of motion. So we're going to have this force too. Force of friction kinetic. So we want to put all these forces on our free body diagram. So when we do our free body diagram, we're going to have, so this direction will be the y direction, and this direction will be the x direction. We've tilted the axes. So let's draw that. So this is x, this is y. This dot, that's the box of treats. That represents the box of treats. And by the way, this angle in here is theta. So let's draw our force of gravity right here. Force of gravity, which is mg. This is the angle theta, 30 degrees. Then we have our normal force right here along the y-axis, and we have the force of friction along the x-axis in the negative x direction. So we apply Newton's second law to the x and to the y direction. So we apply it to the y direction, we can get the normal force. And then we apply it to the x direction, we can get the acceleration in the x direction. So let's apply it to the y direction. Sum of forces in the y direction equals Fn minus mg cos theta. Since it's not accelerating in the y direction, this equals 0. So therefore we get Fn equals mg cos theta. Also, once we have Fn, we can get force of friction. Force of friction kinetic equals UK Fn, which is UK mg cos theta. So now that we have the force of friction, we apply Newton's second law along the x-axis. Here's what we have. Sum of forces in the x direction. I'm taking this way to be positive. So we have the component of gravity, Fg, let's call it mg. So this is mg sine theta. And then we have the force of friction in the negative x direction. So minus force of friction, which is mu k mg cos theta minus mu k mg cos theta. Sum of forces in the x direction equals mass times acceleration in the x direction. So it equals max. Now you can see the m's cancel out. Right? This cancels. Every term has an m. So we solve for ax. So ax equals g sine theta minus mu k g cos theta. And then we put in our numbers. We're going to have 9.8 sine 30 degrees minus 0.3, 9.8 cos 30 degrees. And that is the acceleration down the ramp. And oh, that equals, if you work it out, you get it equals 2.36 meters per second squared. So that's AX. 2.36 meters per second squared. Oh, the forces in the x direction. So the forces in the x direction are, okay, so we got the component of gravity down the ramp plus the force of friction kinetic up the ramp. So it's two forces. Maybe I should have written this more clearly. So sum of forces in the x direction is force of gravity sine theta minus force of friction kinetic. And then I put in force of gravity is mg, so I have mg sine theta. Force of friction kinetic was right here. Mu k mg cos theta. So we have minus mu k mg cos theta. Any other questions on this? Okay.